Okay, here's another, sorry, I'm just looking at this one. Okay, another improper integral. Due to the fact that the interval of integration includes an infinite discontinuity. In this case, the function 1 over x minus 5 squared has a vertical asymptote at x equals 5 right here. And so the graph of y equals 1 over x minus 5 squared, which I've graphed in Desmos here, will never intersect that x equals 5 boundary. So in terms of area, this is an unbounded region. And so now we're looking at the area from 1 over here to 5. So the unbounded portion is over here. So when we set up kind of an artificial right-hand boundary, let's put it over here and call it t, we're going to need to allow t to approach 5 from the left. We're not approaching 5 from the right. We're thinking of it as, so one of our limits of integration is 5 here, so we're not integrating at all beyond 5. So we think of this right-hand boundary as approaching 5 only from the right here. So in terms of expressing this as a limit, which should always be your first step with improper integrals, is write it in its limit form. So this would be the limit as t approaches 5 from the left of the integral from 1 to t. If you're wondering, so you don't need to be able to graph this function overall to be able to see which way to express this thing as a limit. The important thing is just that you know that this graph is going to have a vertical asymptote, which is an infinite discontinuity at x equals 5. So if I was doing this without actually graphing the function, I would say, okay, my interval of integration is 1 to 5, but I've got a vertical asymptote here at 5. There's no problem at 1. So I can integrate at 1, but I'm going to have to approach 5. And from the left, I can see it there. Okay, so as far as evaluating this, I think I'll get a new page. So the first order of business, once we've set this thing up as a limit, is to find the antiderivative of 1 over x minus 5 squared. So I'll do that on a new page here. So I'm going to look at it just as an indefinite integral for a minute. Integral of 1 over x minus 5 squared. So this can be integrated using a u substitution, where u is equal to x minus 5. So du is just equal to dx. So this is just equal to du. And this thing has the form 1 over u squared du, which is the integral of u to the negative 2. And so using the power rule, the antiderivative is u to the negative 1 over negative 1, which is negative 1 over u, x minus 5. Okay, so back to where we left off with our improper integral. Right here. So x minus 5 squared dx. It's important I say it out loud because it's so hard to read. I'm sorry again for my handwriting. That's a 2, that scribble there, then the exponent. And so we already talked about how we can set this up as a limit with t approaching 5 from the left of the integral from 1 to t of this expression here. Okay, and we have an antiderivative. So this is the limit as t approaches 5 from the left of, our antiderivative is negative 1 over x minus 5. And this is as 5 goes, as x goes from 1 to t. Okay, so this is, so we're going to plug t in first. So I'll put the limit in front of that. So the limit as t approaches 5 from the left of negative 1 over t minus 5. The limit only applies to that expression of t. So now we'll do minus Now I plug in 1, so negative 1 over 1 minus 5. Okay, which that would be negative 1 over negative 4. So you'll have a negative over here, so this will be 1/4. Right? Negative overall, because you have a negative here, and then this is a negative. So the 3 negatives, it'll end up being negative overall. Okay. The limit as t approaches 5 from the left. Let me get a... Oops. Okay. So as t approaches 5, that means that this denominator is approaching 0. We've got this negative up front. So remember, when the denominator is approaching 0, this is when we need to think carefully about, okay, so is it approaching 0 through positive numbers or negative numbers? Okay, and so to think about that, so t is approaching 5 from the left. So we're using, if we were plugging in values to investigate this limit, we would plug in values like 4.9 or 4.99. So if you take 4.9 minus 5, that's going to be a negative number. You take something slightly less than 5, right, because we're approaching from the left, slightly less than 5, and then subtract 5, you're going to end up with something just slightly negative here. And so since this limit has the form negative 1 over 0 through negatives, so we can determine the overall sign would be positive, right, when you consider the negative in front. Hang on, let me clear out some space. Then this limit right here is approaching infinity. And so we've got infinity minus 1/4, so that's approaching infinity, which means that this improper integral right here diverges.